So in the last video, we went over the uses of the binomial expansion. And in this video, what I'm going to do is I'm going to explain some ways to basically solve questions on your problem set. So let's start with the first one. Actually, I'm going to use yellow. So let's start with the first one. So find the term containing x cubed in the expansion of x plus 2 to the power of 11. Okay, so find the term containing x cubed in the expansion of x plus 2 to the power of 11. So remember, we're going to put the choose terms there, and so we have 11, remember, because we say 11 because that's to the power of 11. This term will be x because that's the first term over there, and the second term will be 2. Okay, so the goal is to find the term containing x cubed. So we know right away that if we want x cubed, that this will be a number and the 2 will be a number, and we want this to be x cubed, so this number has to be 3. Okay, I'm just going to use red for that. So this number has to be 3. So if this number is 3, remember this power plus that power must equal 11. So if those two powers equal 11, this must be 8 because 3 plus 8 is equal to 11. And if you recall, the exponent for the second term will be the same number over here. So it's 11 choose 8 x cubed times 2 to the power of 8. So what is this equal to? 11 choose 8 is 165. This is x cubed because we want x cubed. And 2 to the power of 8 is 256. And if we multiply 165 by 256, what we get is 42240 x cubed, and that's our answer. So that's our answer for number 1. Let's do number 2. Okay, so number 2 says find the term containing x to the power of 6 in the expansion of 4 plus 4 x squared to the power of 7. Okay, so find the term containing x to the power of 6 in the expansion of 4 plus 4 x squared to the power of 7. So again, same thing as before, right? We have our choose term, then we have our first term, then we have our second term. Our choose term is going to start with 7 because it's 7 to the power of something. It's something to the power of 7. Our first term is going to be 4, and our second term is going to be 4x squared. Okay, so now what we want is we want the term containing x squared. So obviously we have to look at our variable right here. And what we're going to observe is that it's x squared to the power of what will give you x to the power of 6. And it must be 3 because the 2 and the 3 will multiply to give you 6. So if they multiply to give you 6, then if this is 3, then the second term must be 4 because 4 plus 3 is equal to 7. Remember, these two exponents have to add up to the first term of the choose. And so finally, since that term is 3, this term is also 3. And basically what we have now is 7 choose 3 is equal to 35. 4 to the power of 4 is 256. Okay, and 4x squared cubed is 64x to the power of 6. And if we multiply everything all together, we get 57340 x to the power of 6. And that's the solution we're looking for. And we want x to the power of 6 because that's what they asked for, and this is the term that's in front of it, or the coefficient that's in front of it. Okay, so number 3. This is kind of tricky, so let's do this one. It says find the constant term, so it's the constant term in the expansion of 3x squared minus 1 over x to the power of 9. Okay, so whenever you see something like this and you say 1 over x, a good thing to do is sort of just convert this into an x to the power of something. So another way of writing this term is really just 3x squared minus x to the power of negative 1. Because remember, x to the power of negative 1 is 1 over x to the power of 9. Okay, so really we're going to be playing with this, not with this. I mean, they're equivalent, but it's easier to use this than anything else. So how do we do this? So it's the same deal as before, right? We have 9, so we have our choose term, then we have our first term, and then we have our second term, right? And our first term is 3x squared, and our second term is negative x to the power of negative 1, right? So what we need to do is when we're trying to find a constant term, the power over here, so this is a positive power, positive exponent, and over here we have a negative exponent. And when we sort of multiply these out, when you multiply variables and they have different exponents, the exponents will add. And what we want is we want the exponents to add up to 0, because x to the power of 0, like x to the power of 0 is equal to 1. In other words, it's a constant. So what we want to make sure is that this power, whatever power we have here that ends up being, when it's added with the second term and whatever power ends up being, these two powers should add up to 0. So how do we do that? So the best way I can think of doing that is sort of writing a table. Okay. So let's say we have an x squared table and we have an x to the negative 1 table. Okay. So remember, this is our r value and our index starts at 0. Okay. So let's basically write 0 over here. If that's 0, then this is 0, and then this becomes 9, right? Because 9 plus 0 is equal to 0. So let's start with r equals 0. So negative 1 to the power of 0 is 0, and x squared to the power of 9 is 18. These two do not add up to 0, because 18 plus 0 is equal to 18. So r equals 0 is out of the question. So let's try r equals 1. Okay? So if we have r equals 1, basically these will change. So if r equals 1, then this is equal to 1, that's equal to 1, and this is equal to 8. Now this term doesn't matter. Remember, 9 choose 1 is just a number. We're just looking after, what we're after is really to make sure that the exponents of the variables end up being, or they sum up to 0. So anyways, so r equals negative 1, so this is x squared, 2 times 8 is 16, right? And negative 1 times is negative 1, and these definitely do not add up to 0. Let's just keep going with our table here. So let's do r equals 2. So if I erase it there, so you can see the trend basically. That's 2, and that's 7. 2 times 7 is 14, and this is equal to negative 2. So one thing you can observe right away, and this doesn't work because 14 plus negative 2 is not 0, so is that this power keeps decreasing while this keeps increasing. So let's try r equals 3. I'm going to extend this line a little bit more. So r equals 3, so let's try that. So if I do r equals 3 here, that's going to be 6, and that's 3. 2 times 6 is 12. Negative 1 times 3 is negative 3. Still does not work. R equals 4. You can probably project in your head what the number will be, but I'm just showing it just to make sure that it's clear. So this is r equals 4. That's to the power of 4, and that's to the power of 5, right? Because 5 plus 4. So anyways, 2 times 5 is 10, and negative 1 times 4 is negative 4. Still, no go. Let's try r equals 5. If we do r equals 5, so this is 5 here, that's 5 there, and then that's 4. So 2 times 4 is 8, and this is equal to negative 5. Again, 8 plus negative 5 is not 0, so no go. And so finally, let's try r equals 6, and hopefully this is the one that will work out, and we'll see why in a second. So if r equals 6, that's 6, and that's equal to 3. So 2 times 3 is 6, and negative 1 times 6 is negative 6, and this, if you add these two up, end up being 0. So which is exactly what we want, right? So since this is the one that we want, let's just expand this. So 9 choose 6 is equal to 84, okay? 3 x squared to the power of 3 is equal to 27x cubed, or x to the power of 6, sorry. And this one will simply become positive. It's positive because it's to the even exponent, x to the power of negative 6, right? And if these two add up, this one and this one multiply, the exponents will add up. So basically you'll get 6 plus negative 6, which is 0. So it's 84 times 27, which is 2268, times x to the power of 6 plus negative 6, which is 2268 times x to the power of 0. And we said that x to the power of 0 is 1. so that's equal to 2, 2, 6, 8. All right, so that's how we do that problem. And this kind of problem, finding the constant term, is pretty popular sometimes. We're going to do one last problem, okay, which is going to be a little bit lengthy, but you can figure it out. And this is going to be very useful when we do this. So the question is, find the x squared term in the expansion of 2 plus x to the power of 4 times 1 plus 1 over x squared. So once again, whenever you see a reciprocal function, the first thing that I suggest you to do is just turn it into where you have just basically an exponent. So 1 plus x to the power of negative 2, and that's that. So in other words, we have to expand this, multiply with that, and figure out which term is the x squared term. So what I like to do is I'm just going to rearrange this. So I'm going to say this is 1 plus x to the negative 2 times 2 plus x to the power of 4. Okay, so let's basically expand this. So we can't expand this because there's no power to it, it's just to the power of 1. So it's just going to be 1 plus x to the negative 2. But we can definitely expand this, okay? And I mean, I can write everything down here if you want, but should I? I can, yeah, basically I'll just do it. So if you recall, this is 4 choose 0, right? 2 to the power of 4, x to the power of 0, plus 4 choose 1, to the power of 3, x to the power of 1, plus 4 choose 2, 2 to the power of 2, x to the power of 2, plus 4 choose 3, 2 to the power of 1, x to the power of 3, plus 4 choose 4, 2 to the power of 0, and x to the power of 4. Okay, so I'm just going to go a little bit further down, and this is still equal to 1 plus x to the negative 2, right? And I'm just going to basically do this in one step. I mean, you can take several steps to do it, but I'm just going to write that this is equal to 16 plus 32x plus 24x squared plus 8x cubed plus x to the power of 4. Okay, so we still have to expand this because we have this term times that term. So if you look into this, 1 times each of these will just basically be 16 plus 32x plus 24x plus 8x cubed plus x to the power of 4. So in other words, I just took this 1 and multiplied by each of these terms. Now I have to take the second term and multiply by each of these terms. So I'm going to write that below. So that's going to be 16x to the negative 2 plus 32x times negative 2, so that's going to be 32x to the negative 1, because remember, this is a silent 1 there, and the negative 2 plus 1 is negative 1, plus 24. This is x to the power of 2 times negative 2, so it's just going to be 24, because x to the power of 0 is 1, plus 8x, because negative 3 plus negative 2 is x to the power of 1, and then finally plus x squared. So if you observe, the only two terms that we're sort of really, oh wait, let me just make sure, oh sorry, I made a mistake here, I should have put squared over here. So the only two terms, remember, the questions asked us, find out what the x squared term is. So the only two terms that we're really interested in is this term here and that term there. So in other words, the x squared terms over here. So really, what this is equal to, it's equal to whatever plus 25x squared. So if we want our answer, it's just basically 25x squared, and that's it. All right, so I hope that was helpful in basically understanding the binomial theorem and doing a couple of problems. Start working on the package set, and I'll see you in class. Take care. Bye.